Yeah, thank you very much. Can you see my slides already?
Yes, perfect.
Okay, perfect. So yes, in the project of NewsEye, I was mainly working with the use case of migration. And within this case study, mainly with remigration processes, historical remigration processes. This was my main interest in this project. And from the beginning of the project, I actually had a lot of problems with creating a corpus. Because my main interest when researching migration or also return migration is discourses and argumentations. That's what I want to research on, and therefore I need to create corpora. And this was one of the main issues from the very beginning. And during the last years, I was trying to find methods how I can actually create my corpora I then want to work with and do qualitative research on. So yeah, just a short overview about this presentation. First, I want to talk a little bit about the motivation. Why is it important for me to create specialized corpora? So a topic-specific corpus on return migration. Then I want to talk a little bit about why is it important that to have like a representative corpora and good quality corpora. What are the challenges to go there? And always connected also with the topic on return migration. What kind of methods actually exist to improve the quality and the representativeness of corpora, and what kind of methods did I use? Then I'm going to do the method of using LDA and JSD to actually find similar newspaper clippings and to distinguish them between relevant and non-relevant articles. And I will conclude with limitations, of course, of these methods. So yeah, what is the motivation to create corpora on return migration? So while the history of immigration today is actually very well researched, this is not the case for return migration movement. And when I talk about return migration, I mean the return of a person to the country of origin after spending a longer time abroad. If you're talking about historical return migration movements, there have been quite a lot and quite a big return migration movements, like those people who emigrated to overseas, like America, and returned back. Also the remigration and repatriation during and first and during the First World War, and also after, and the same for the Second World War, the repatriation of prisoners of war, of refugees, and so on. So these are all like return migration movements I would like to research on. And there's actually quite a lot about these movements in the newspapers. So one big motivation is actually to create empirical material to research the historical return migration movements. And newspapers, therefore, are rich and also an available source. There's a lot. I mean, if you see the newspapers as a whole, it's actually a quite small discourse, but there's actually an important discourse in the newspapers about return migration. And creating this corpus for me is important because it is actually the basis for my further analysis, for qualitative but also quantitative analysis, especially discourse and argumentation analysis. So what we can find in newspapers is like very different kind of reportings. It is advertisements, it's appeals, it's of course news, and also letters from returnees. So there's like a lot of different kind of reportings on return migration, which are very interesting to look into them, and especially also the discourses that are going on. And I'm mainly interested in questions on how how it was talked about, these returnees, were they perceived similar than immigrants that were coming, or were they perceived different? Were they welcomed in the home country when they returned, or were they seen as a burden? And did this discourse change over time? And also, was there a different discourse on different groups of return migrants? So yeah, it is of course, if creating corpora, it is of course important that this corpus is representative and also has a good quality. This is important because of course the historical studies, they rely on the quality of the sources to actually get valid results. So there's two kinds of criteria for the representativeness and quality of specialized corpora. If I talk about specialized corpora, I always mean like topic-related corpora, so corpora that are about a specific topic. So first, this is the external criteria for quality and representativeness. These are factors which actually are always important when working with historical sources, and our main factor of source criticism. Are the sources I'm using reliable? Are the sources that I'm using representative for this topic? If I'm talking about newspapers, there's always the questions, do these newspapers actually cover all different newspapers for this time, for example, or are there important newspapers missing out? And of course, always the question about the quality of the data. And also, when I keep talking about historical newspapers, is the digitization, is the OCR good enough? Is always one important question to have quality analysis on it. And then there's the internal criteria, which actually is the size of the collection. And this means that when keywords are being used to create topic-specific or specialized collections, researchers often have to weigh up between a collection that either misses relevant articles or, on the other side, has a lot of noise. And that's actually something I'm concentrating on, like on the internal criteria and what is important to get like a good size of the corpus, and what kind of challenges I was facing with my own research while trying to get a good corpus. So the first challenge, of course, is that return migration is a concept that's actually very difficult to trace by a single keyword. So there are a bunch of keywords that lead to relevant articles, which is, for example, Rückwanderer or Rückkehrer. It's all terms that actually are meant for returnees and for these very specific persons. So if I'm using this very clear words that lead to relevant articles, I will get relevant articles, but at the same time, I'm missing out a lot of the newspaper's articles on return migration, because it's not always mentioned, not always, the returnees are not always mentioned. So sometimes it's talked about refugees that are coming back home, or immigrants that returning home, and so on. So this is concepts that are really difficult to find just with single keywords. Then of course it's possible to combine keywords, also with the distance search, to search specific words within a specific distance. But what is complicated there is, especially in German, there's a lot of word flexions. This makes it very difficult to actually search for all the different word flexions. And also, it's quite difficult to not miss out important search terms. So with what am I combining these words, and what am I combining not? And also quite a lot of these word combinations will lead again to non-relevant articles. Then of course I have the possibility to broaden the search and just search for keywords that are not as close as, for example, returnees, which means I could search for return, like Heimkehr or Rückkehr or Rückwanderung, return migration. But those words also lead to a lot of articles that are not relevant for my own research. I will show some examples about this soon. And of course, this is the problem because these words have different meanings in different contexts. So actually, I'm showing an example on this. So the same word, like Rückwanderung, which is which is a broad word for coming back, translated in return migration, but it's an ambiguous word to search for return migration. So with the same word, I can get an article that talks about immigrants in America that want to return to Austria-Hungary after a crisis in America. This is the first article here. And there's another article that actually talks about the return of massive dams to their primal waters. So it's a totally different context, but has the same word, keyword, which I used to find these articles. So one of this is relevant and the other one is irrelevant for my own research project. So yes, what kind of methods do there exist to improve the representativeness of the corpora? So one of it is to use Boolean queries. So to combine search queries, I already mentioned that a bit. The problem with that is it can impose bias and it's complicated through word reflections, which I already mentioned. Then there's another method that actually comes from the computational linguistics. It's called relative query term relevance, RQTR short method. The method is as complicated as the name. And actually this method calculates the degree of precision and recall. I'm just trying to give an example. For example, if I'm trying to find articles on immigration, there will be articles that are relevant too, but do not contain the word immigration. So I could use another word like terrorism, for example. And this method measures how relevant terrorism is for the topic on immigration. It's a calculation, mathematical calculation you can do. And the more relevant this term is, the more useful it is for you. If it's not very relevant, then it actually brings more noise to your corpus. This method can be very useful, but it's actually quite, it's elaborate with the calculations you have to do and to find words you can connect. And then there's a method that is, then there's methods that are based on text mining, and that's actually then going closer to the method that I'm using, like similarity-based word sense disambiguation, which actually this kind of methods assume that similar senses occur in similar contexts. So if a word has, if specific words have similar senses, it's assumed that they also appear in similar context, and the similar context actually can be found. So yeah, this is basically the idea of using similarity methods. And one of these possibilities is to use LDA, so topic modeling, and the Jensen-Shannon distance method, which actually measure the similarity between newspaper clippings in my case, but also between documents or even between document groups. This is working in a way that with topic modeling, I'm creating the topic distribution of each article I have, and with the Jensen-Shannon distance, I can measure how close those articles are, or how big the difference between those articles are. So this actually had 4 main steps to go from there, which actually was first to create and to annotate a sample corpus. I was creating a corpus that was about 200 had the length of 200 articles using keywords, ambiguous keywords like Heimkehr, Rückkehr, Rückwander, heimgekehrt, Heimkehr, and it's all words for return, returning home, returning back, and so on. And I was annotating those articles. So I gave a 0 to those newspaper clippings that were irrelevant and a 3 to those who were relevant. And as you can see here, this is how the output looks like. Here's the text, and every text has the annotation 0 or 3. So afterwards, I was dividing this corpus into a training corpus and into a test corpus using a binary mask, just like creating two corpora. One was used for the training and the other one for the testing. With the training corpus, I was training the topic modeling algorithm, which actually made it possible to have like a topic distribution for every single article I have in this collection. It kind of looked like this. So every article has a specific distribution, topic distribution, and that's also how they get compared. So the test corpus was actually there to check if retrieving similar newspaper clippings worked. So if I'm using, and I'm going actually to the next slide to show this a little bit better. So if I'm using the test corpus, which has so far unseen articles, for each article in this test corpus, I was finding with the Jensen-Shannon distance, I was finding 10 similar newspaper clippings from the training corpus. And those, all of those newspaper clippings carry the information of their relevancy. So I have found those 10 articles that are the most similar to these articles, for example. Then I was calculating how possible it is that this that this article is actually relevant or non-relevant. So if 60% of the found articles are annotated, manually annotated as relevant, this article would be put to the group for the relevant articles. If on the other side, 60% of the found most similar articles were annotated as irrelevant, this article will be put to the section of irrelevant articles, and so on. And this will be done like for every single article in the testing corpus. And since also the testing corpus carries the information, the manually annotated information on relevant and non-relevant or relevancy, it can be checked how good this method worked. And actually, to be honest, I was very surprised that it worked. I was not expecting it. It was kind of like creative approach, like, oh, let's just try to put something together that works. And then I did it, and it worked really well. So this is the results for the test corpus. It shows like 3 are the articles that are relevant, 0 are those that are irrelevant. The first column is collecting all articles that are relevant, and the second one all irrelevant. And as you can see, only a few articles here from the actually irrelevant articles have been marked as relevant, and only very few of them from the relevant ones have been marked as irrelevant. The method has accuracy about like 80%, so 80% more or less, in an average, more or less 80% of the articles were actually selected correctly and as a relevant or irrelevant article. And this is then, in the end, the output, how it looks like. So I have relevant articles and I have the non-relevant articles. The relevant here one is about prisoners of wars coming home. The non-relevant here talks about a theater piece that was called Heimkehr des Tobias, Homecoming of Tobias. So Actually, the method correctly told me this one is not relevant for return migration, and this one is relevant for return migration. So what I got in the end was a new collection with articles. Because after the testing corpus, I was using the whole corpus which I had, which was several thousand articles. I was using also just the same method, comparing them to the 200 manually compared articles, and was creating the corpus and getting a corpus that mainly contains articles that talk about return migration. So it took me quite a long time, but now I have a corpus that I can finally start doing the research I want to do. And yeah, I hope I was able to kind of make this clear. Otherwise, oh no, I wanted to talk about limitations too. So yeah, what are the limitations of such methods? Yeah, when working with digitized newspapers, what is important that it requires article separation. So yeah, this is a case that actually makes it often impossible to even create corpora if there is no article separation, or actually also very bad article separation. So I think that we are still in a phase where missing article separation is one of the biggest problems to even be able to create corpora, and it's a very important future step. Yeah, to continue this work. Then, of course, this method for this method, keywords are still necessary. Trying out other methods with no keywords have shown as not useful so far. And it depends on manually annotation, but I believe manually annotating 200 articles and then getting a corpus of several thousands, which is quite correctly distinguished between relevant and non-relevant, is actually not such a big deal. And every researcher can do this with its or his own research question. I've also tried the same method with another research question, for example, on the topic cancer. Like in German, we have a word for cancer, Krebs, which is also a word for other things like crab. And also on this topic, it worked quite well. So yeah, if I was explaining this too fast, not well enough, there is a Jupyter notebook on GitHub, which actually shows the full code and the explanation. So yes, you're welcome to check this out. Thank you very much.
Thank you very much indeed, Sarah, for going through all of this experimental methodological explorations that you've done. So thanks very much. And we'll come back to questions. So if you have any questions for Sarah, please feel free to add them into the chat. And now we're already at our final presentation for this session. If our next speakers could come on, please. That's Quan. Hi, great. Hi, Lidia. And Quan, so Lidia Pivovarova and Quan Duong from the University of Helsinki, Department of Computer Science. So Lidia is postdoctoral researcher at the Department of Computer Science at the University of Helsinki. I love what she said in her profile. Her favorite research objects are the largest are the large collection of digitized newspapers, and she particularly enjoys cross-disciplinary research. Quan Duong is finalizing his master's thesis actually on automatic music generation, which is very interesting. And his research includes various topics such as artificial intelligence and NLP. And today they're going to be talking about towards automatic discourse change detection. So thanks very much. Over to you.
Hello, can you see my screen now, right?
Perfect.
Okay, so yes, both Quan and me, we are from computer science department. So now we'll share computer science view on digital humanities problems, and after being in NewsEye project and collaborating with historians closely for several years, I have my opinions on how multidisciplinary research should be done. And I now want to share with you methodology to solve one particular task, which is discourse change detection. So our goal here is automatic detection of discourse change in a large collection of text or news. What is discourse? I'm not going in this discussion actually, because it's problematic notion by itself. But we're looking for change in the most discussed topics, opinions, attitudes, themes in the news. And this goal is relevant for many digital humanities applications, but methodology for this is yet not established. And time series analysis, of course, it has many applications in computer science and many methods for that, but adopting directly from signal processing literature, for example, it doesn't work for textual data. It just, they have different underlying properties, underlying distributions. This is discrete data and so on. So we need some specific methods. But now we got into problem, but in digital humanities, research questions are very complex and they involve a lot of uncertainty. So ground truth, where as computer scientists, we're used to optimize our models to some ground truth and to make numerical evaluations. But in digital humanities research, it's not always possible. So even if our colleagues, historians, they would like to annotate data, but they're not always able to annotate, especially something so high level as discourses. It's very complex. And besides, very often DH research deals with a single use case. Like, for example, in NewsEye, collaboration with Yanni and others, we are studying discourse change in 19th century Finnish newspapers, but we have only one 19th century. So we cannot, and we are looking for corpus artifacts. Discourse is a corpus artifact, and discourse change, it's a corpus artifact. So we cannot split corpus in some training and validation and test sets as we used to. We have only one use case. So that's limits models which we could apply and methods we could try. Solution which I propose is to use synthetic data set, and this is what we tried with Quan. So we use synthetic data set to emulate discourse change. We produce not only single corpus, we produce as many corpora as we want from synthetic data sets. And we produce in these particular properties, like this theme is increasing, this one is decreasing. And that's why we can apply super red machine learning models and validate them. And it's allows for us more options. So I now go to more specific part. So this is our data set. We used Yle corpus. This is all data sets we are using here are freely available. This is Finnish news articles by biggest Finnish broadcasting company. Which you and since it's modern use, each article is accompanied with keywords or labels. We choose 12 big categories, which we use as our discourses, like pseudo discourses. These are well separated topics. But of course, there is some overlap, like with our cars, music, nature, elections, diseases, employment, hockey, very important for Finnish news, culture, crimes, schools, food. Of course, they are overlapping. Of course, there could be a single article that belongs both to politics and nature, or I don't know, schools and food, and so on. And this is our intention. because text data are never clean. Like article is never about a single theme. So we try to use real data. And so we choose these 12 topics, and for them it was about 200,000 articles. And from these we sampled 1,000 data sets. For example, I'll show you how it's done. And these 1,000 data sets, they have some properties we would like them to have. So one category follows a certain pattern, and several others are sampled evenly. We are not always sample all 12. We want some randomness here, so we choose one topic. Here, it's example, it's production. What is it? No, employment. Yeah, and this is increasing here because we sample it like that, and also we sampled some other articles from other categories randomly, like using just random noise. And here we ignore original date of the article. We think, so these are pseudo date, and these are time points. We have 100 time points. On each time point, we sample articles so that we follow these shapes, ignoring their original date. This is synthetic data set. And this main pattern, main category, it could follow 7, well, actually 6 plus 1. So it could be either going down or could be spike down. It could be some spikes up. It could be increasing or like that. It also spikes down, like these are regular events. And also it could be stable, but noisy. All these patterns are noisy as we expect in a real data set. So we can think about it like this one would be some decreasing topic. And this one would be some regular topic like Christmas, maybe, something like that. So we try to emulate real discourses. And now we have data sets, we could evaluate our methods. So we have time series, 100 time points. At each time point, 200 documents. And we have 2 tasks here. First, find a subset of documents that follow non-stable pattern, if it exists. Because sometimes we use stable pattern, so everything is stable. Nothing is increasing or decreasing. So task 1 is to find this blue line in the left. So find some subset of documents which are about certain theme and which are not stable. And second is to find pivot points. So find points in time series when it switched from stable, noisy stable to noisy non-stable. How we do it? We have 2 steps. First, cluster our data set, all data set, we ignore dates, we apply clustering. We use 20 clusters here, and the number of clusters is bigger than number of categories. And it doesn't matter because here we're interested only in non-stable pattern. We don't care about all our clusters. So we cluster them, and then for each cluster separately, we build a time series and apply a method for classifying this time series and finding pivot points. For first step, we try k-means clustering and topic modeling, LDA. For second step, we try linear regression and as a baseline, and also neural network of 2 different kinds. And these steps could be done separately. Step 1 is unsupervised, so we could apply it to our data set. Step 2 is supervised, but we train it on synthetic data, so we have as many data as we want. This is our best model, briefly. So we have this time series. When we process it with 2 neural networks, actually like RNN, bidirectional LSTM, and then convolutional network, then we can concatenate results. and produce two outputs simultaneously. So first, the binary prediction if this is a stable time series or non-stable. And second, for each time point we predict, is it within non-stable period in this time series or outside. And this is supervised model, this is neural network model, which requires training data, but it could be trained separately, and it's trained separately. We even don't need any text, just train it on artificially produced time series. And now evaluation, as I said, all evaluation is focused on this non-stable trend, which we know which category is non-stable because we generated data set like that. And we do it on several levels. So first on data set level, it's accuracy if major category defined as changing is indeed changing. Then on document level, so how many documents which we decide they belong to this non-stable trend actually were sampled for this non-stable trend. And this we could compute with recall precision or F measure. And then last evaluation measure is pivot point detection. It's round index, the standard for that. And this kind of independent evaluation. And this is done only for non-stable clusters. So evaluation emulates this use case that we get corpus, we find some trend, and we show to a user only this changing trend. We don't show anything else. And our evaluation is focused on that. These are results. First thing that we could see here that numbers are really different. So with synthetic data sets, adding enough noise, choosing with functions and so on, we could discriminate methods. We could somehow find which method is the best. Second, what we can see here that k-means is better for, regardless of the second step, k-means is almost always better. With only one exception, so LDA in combination with convolutional network does not work very well on document level, which means it finds too many, it finds noisy clusters, but still it can put pivot points in the right place. This is interesting result. I don't know why is it like that. It's something we need to continue working on, but it's interesting result by itself. Okay, so this all is done on synthetic data set. Now we decided that this is our best model, and we start applying it to real use cases. Well, real to the extent that no synthetic data anymore. First use case is STT. STT is the biggest Finnish news agency, NewsEye, and this corpus is also available. We choose dates different than was in Yle corpus. So this is again, it's the same language and the same genre, Finnish news, but different source and dates. And we choose 2 years and build time series using weeks. So we have in 2 years 100 weeks, and we chomp it on the sides. And these are our results. So we found some clusters. As our model work, most of the clusters are classified as stable, so we're not looking into them, but some of them found as non-stable, for example, this one. And I would like to stress how we work with that. So first we apply our model without any hypothesis. When we look on what it found, so it found that this cluster is not stable, and it found 2 non-stable periods. So model says that all these, everything that we see here is just noise. This increases and decreases, not significant, but there are 2 non-stable periods. And when we started reading these documents, and we found that this is sport cluster, something about sports, competitions, and so on, and found very quickly. but this is Hockey World Championship. You can see dates are not perfect here, so probably pivot points should be a little bit to the left, but it's there. It's pretty close. And this is Olympic Games, and they are discussed, of course, a bit earlier, a bit later after the event. So yes, it's working. It found something. The model trained on synthetic data set found something in a real data set. And this is another example. Here again, we have some model predicted something interesting here. And when we start reading this document, it was something about politics, parties, and so on. And it's actually corresponds to parliamentary elections in Finland. Yes, and then a second example. This is State of the Union corpus. State of the Union annual addresses by US presidents to Congress. And this corpus contains data for 200 years. Annually, President talks about current situation and politics and priorities and plans for the next year. So this is different language, English, and this is a different genre. But model, we apply the same model trained on a Finnish news synthetic data set here. We choose 200 years and split it in 2 years, and document here is a paragraph. So these are long speeches. We split it into paragraphs, applied our method, and found something interesting. For example, this cluster, quite specific, it has very specific spike in the middle. This is presidency of Theodore Roosevelt. I don't know actually what's so specific about him and his presentation style, because we didn't find anything for other presidents, not so clear, like specific. But this we found in the data. The next thing, model predicts some 2 spikes here, and there are a lot of discussion about economics, something, and definitely the second part corresponds to oil crisis. And this is really interesting to read, because since this is a State of the Union, so President is telling how we are planning to revive our economics, how we're planning to encourage people, and so on. They are not telling, oh, we are in a crisis. No, it's not. But there is some change in the discourse which we are able to find. I'm not sure about the second part here, but it's something also like revitalization after the war. I think so. It's my guess. And then we also found something like some period relevant to war, sovereign states, legislate, all this kind of discussion here. And so this is Mexican War, actually, and this is Civil War somewhere, and it ends, according to our model, somewhere the beginning of the President Grant period. So it clearly relates to this constitutional discussion and war and so on. But I'm not an expert in American history, any history. So it's indeed it needs to be interpreted by historian, but now we can show historian not just a random model trained with some random parameters, but actually we can be certain, like this 70% certainty as I showed you before, but something going on interesting here. So look at this document from this cluster, maybe you could find some interpretation. That's all basically. Yeah, I would like to tell it we are not yet, well, we are proposing some particular model, but even more, we propose some methodology to work with synthetic data, which allows us to train supervised machine learning models, which are like usually more successful than unsupervised. At least to have more possibilities here. We can apply, we can evaluate numerically, compare, improve our models. And as we could see, a model trained on synthetic data set finds something reasonable in real data, so it's quite promising. This is how I see future work. So we would like to apply it to real use cases, and then probably we need to make our synthetic data even more challenging, so we could train even more models, and so on and so on. I think it could be quite productive to work in this way. Thanks for your attention.
Thank you very much to both Lidia and to Quan.